Lecture E01, natural stone, super interesting material. Really nice to work with. Content of this lecture: introduction, properties of stones, classification, acquisition of stone, applications of stone, and design considerations and aspects to think about. Stone is a natural material, as we are aware of. Thus, we need to deal with the characteristics of this natural material, which always, let's say, makes makes engineering life interesting, makes designers' life interesting, because we need to deal with these different characteristics as a result. In the means of construction, stone has been used in applications from rain screen till solid structures, till massive structures, which is an obvious one. And it's a unique material. It appears unique. Each stone is different, which makes it a very special material to deal with. When we think about the stone properties, they vary a lot. We have very different types of properties due to the different types of stones, with the consequence that there's high durability, high density, a high compressive strength, but a very low tensile strength. So theoretically, depends a bit variation with the different types of stones. They cannot take any tensile strength, but can take a lot of compressive strength, which means that you mainly go with dead load oriented structures if you go for structural use of stone. If you go for cladding, you have to see how to deal with the reinforcement in a later part of this lecture. Fire resistant, impact resistant, failure mechanisms. It's a brittle material, which means that we have to deal with design setups which allow that if there's an impact, the material stays in position and doesn't find a way to collapse or conflict with our main structure. We have different, a huge variety of densities and characteristic strength, compressive strengths. When you look at the characteristic compressive strengths, for example, from 90 to 300 Newton per square millimeter, this is a huge range, which means we have to deal with a huge range of different properties of different types of stone. As a result, again, tensile strength, you see it's very limited. So brittle material not being able to take a lot of tensile strength. And porosity, that's quite large, also wide range depending on what kind of stone we deal with. And that's an aspect, this porosity, that's an aspect which we have to take in consideration deeply when we think about how to expose it to water and how to deal with that. In the geological history, there are some different types of stones. Some are easier to be shaped, easier to handle, like limestones. Some are harder, and by that more durable. For example, granite as a material. And when we go to the classification, how does stone develop? How does stone happen to be? We have three ways of creating or having stone being made. Sedimentary, so stapling of older former stone and then being connected. Igneous, formed by molten rock, the volcanoes as a system, and metamorphic, which is heat and pressure because of a number of layers on top of it. This material itself is compressed. Former sedimental stone is compressed, and by that becomes a new type of stone. When we go for sedimentary stone, three ways of compacting them: deposition, and purely eroded material washed down the rivers into the sea and then stapled at a certain point, compacting a bit. Then decompactation, depending on the pressure above, these layers appear, and then cementation, which is the final setup, which means after the compactation, pressure puts the particles together and at a certain point laminate them together as igneous. The volcanoes, so the eruption itself, which is defined in extrusive igneous rocks, which is the magma being sprayed out, being lava, and then finding its position and then cooling. This ends up in basalt as, for example, a main as one of the types of natural stone, versus the intrusive igneous rocks, which are the rock, which is the magma, which didn't find its way to the surface of the ground, but then stays there and cools down and creates granite as a structure, very solid, very strong material to be used. Metamorphic stone, the stone which is compacted by load, which is put under high pressure and high heat by inner magma, which heats up this area. Marble is a typical material, so a limestone material which is then compacted into this metamorphic stone as material. Acquisition of stone, this is a huge device which we always like. Acquisition is happening by quarries, so large areas where rock is given, which we cut off of this area. It's broken in larger pieces and then cut down into smaller pieces, so that's maneuverable, which could be then used and then transported. The acquisition of stone starts by identifying where it is positioned, then leveling it and preparing it, making the quarry blocks. Block size is mainly defined by transport out of the quarry to the next position of manufacturing. Then the cutting happens. It's saw systematic, which we discuss in a minute, how to get this cutting done, and then the secondary and tertiary cutting of transport is happening in a later phase, which we see in a minute within these slides. And after this block is cut out of the quarry and brought to the manufacturing site, it's cutted there by various instruments. It's an single wire cutter, which means it's one wire which is constantly moved around the rock. That's what actually happens here, what we see here as well. So it's a single wire which cuts the stone by time in position. That's one way of doing, or having a multi-wire cutting device as this one, a gang saw, a saw which goes this way in one direction, very typical for cutting stone, or a circular saw, which we see here in this sample as it is drawn. Then obviously, with say the robotics appearing also in this field, the robot tool can then handle the cutting devices, the wire cutting, for example, here, to create more free-form spaces by having a wire tilting around the direction which we expect the cutting to be done. This changes a lot our opportunities in producing more free-form stone structures, and it's just, for example, what we see at the top picture, very nicely natural stone, free-form cutted object. Applications of stone, as stone is a very solid and fire-resistant material with good compressive strength. It's mainly used for gravity-oriented massive structures, load-bearing structures. We also nowadays use it as a thin cladding material to use its appearance, its beauty as material. Highly durable, so it stays for a very long time, can be used for centuries. Types of insulation, or types of use of natural stone in facades. Ventilated facade is a very typical type of facade. We have that outer layer, we have that functional zone in between the airtight at the inside, and the outer layer has to be rain-tight. So we may use natural stone as a cladding material being placed at the outer layer of our ventilated facades. Joints between these stones, the joints can be either open or closed. closed with a rubber or with a mortar, then we need to make sure that this inner part is not too much pressurized, so that there's still the drainage opportunity in this system to happen. The typical fixing, that's an interesting one. This is where, say, there are the main differences by different suppliers, different manufacturer in these stone construction environment. The typical fixing you either do with a point fixing, so drilling holes into the stones and then having a point fixing which is fixed to the main structure, either with a bolt or with a bracket, which means you have to have an individual fixing for each of the plates, which is the one way, versus the other setup, which is an aluminium, for example, aluminium bar system, which allows to have certain kind of clamps, which then in a more efficient way bring the stones in position, but you obviously need a lot of more material to get this placed. And here you can see the entire text. Now I get back into the screen of this one. Some nice details how this is done. As said, the closed joint or the open joint, the pressurized facade, and the means of that there's within this cavity there's still the need of having a drainage within the system, and then the simple open joint. So we have the one natural stone here, it's number A, one natural stone here, the other natural stone here, and then the fixing of the natural stone in position, versus the open joint with an extended edge, so that the edge of the stone appears to me to be more slender, versus the glued edge return, so one appearing as one piece of stone as an entire component being glued, having a substructure at the back to keep the stone, the edge in position. As we said, it's a brittle material, so we will not be able to just glue the material and then keep it in position. There has to be some kind of structure at the back to keep the edge as a system. And then we go for this one, where we have this edge return with an glued or sealed situation in this bolt. Again, looking a bit similar to this detail solution as set. Glued veneer, that's, say, an opportunity to use the beauty, the appearance of stone in our designs. That means that we have a very thin layer of stone veneer. Thin in this circumstances means about 3 centimeter, maybe 2 centimeter. Depending on the size of the veneer you'd like to install, transport is obviously an aspect, and then that needs some mortar to be laminated or laminated with epoxy polyester in a more modern way, if this is possible to be done. This is a typical sample of such a veneer, Mies van der Rohe Pavilion, Barcelona Pavilion, where we see that these veneer plates are very nicely brought in position. And another aspect which is important, same with the veneer in timber as with the veneer in stone, this is a mirrored piece of this, and this is a mirrored piece of this. So actually this entire field is milled out of one block of stone, and then they're milled and then flipped to create this nice total picture of the mirrored veneer in position of the for the aesthetics, for the situation which we'd like to reach as said. Alternatives, because of its, say, compressive strength, we go for stone blocks which are stapled, for example, in front of a facade, like a ventilated facade, which then have to be held with brackets in position, typical load-bearing bracket system, which then takes the loads of the natural stone being stapled like a brick system in front of our facade. Design considerations, aspects to deal with when we deal with stone. Stone is a natural material, so the properties are not entirely controllable. We have a certain range of properties. We need to prove the qualities and the properties of each material which we use. Because of this, we need to decide clearly and identify clearly what kind of technology are we going to use, how it's going to function, and who's going to supply us. The quality control is an aspect which is intensively done by the supplier. So we can envision that in one block of stone, with being a natural material, the different qualities have to be checked and then have to be identified if the material goes for this one application or for a different application as a system. The reinforcement, as I said, stone is a natural material, so you may end up in the situation that when you create structural components which by impact load have stress on the back of the system, like we, for example, will have when we install stone in a facade and with a supported system. If there's an impact, the inner side of the stone will get stress. To prevent this being a problem, we are able to reinforce them with some meshes, a mesh system. Glass fiber reinforced plastic would be a typical meshing reinforcement system, as meshes being laminated on the back of a natural stone, maybe even as an edge return support in this situation. And then we are able to fix the entire system to it. Obviously, this is more costly, so you have to identify where you want this to happen and how you're going to deal with that. And then finally, natural stone is a natural material. This means that water can penetrate it, and either the stone is, say, strong enough to withstand any water getting into it and then freezing and then expanding and not breaking the surface, which is one of the key aspects. If this is not possible, we need to do something. Obviously, also chemistry could be part of the water penetrating our facade, which may harm the stone, especially on in a longer period. Natural growths of plants could be an aspect of that with stone. Again, if the stone is not solid enough, it may expand and then by that break. A way to solve this is creating such an additional layer on top of the stone, which obviously is then an additional layer which changes this natural material into more artificial material, which designers has to be taken into consideration as a system. It's really a super interesting material. I really like to work with it, but it also has some boundaries you have to deal with. Nice challenge for the designer. And with this and this last slide of who's involved, I stop this lecture.